So I wanted to make a video just about the different number of number systems that we have in mathematics. Some of the ones that we'll see in pre-cal, some of the ones that you'll see in applied. And if you do kind of notice that we keep on using a certain set of them, and you're like, oh, what's that? Maybe you can watch this video again and get some extra knowledge on it. I just want to talk a little bit about some of the different numbers that we have in math. Of course, we have numbers like 1, 2, 3, 4, and it kind of goes up by 1 like that. And sometimes we call these like the counting numbers. Other people call these, really the counting numbers, that's what people call them. But there is a proper name for them, and these are called the natural numbers. The natural numbers. And the natural numbers do not include 0. They go up by 1 each time, and they're kind of referred to as the counting numbers. Sometimes you'll see that they have a certain form called like this. You know what? No, that's not great. I'm just going to kind of add an extra bar over there. Sometimes the notation kind of looks like this, where it's an N, but there's like another little line through it. I can't really draw it well for that one, but you'll see it in my notes that I have a couple of examples with the other number sets. And you'll be like, oh, what's that symbol? And just kind of know that it's using this double-lined N to recognize that it's the natural numbers. There's another stage to this. It's ones that include 0. So something includes 0, 1, 2, 3, 4, ... going up by 1 each time. We call these the whole numbers. Whole numbers are used, and natural numbers are used, but if we want to include 0 in a number set, then we use the whole numbers. Again, we can kind of have an extra little like bar kind of thing to recognize the whole numbers. You'll see it in the notes again, but it's kind of like this two-lined W, and we call that the whole numbers. There's one other stage here, the integers, and integers are whole numbers, but also negative versions of them as well. So 0 plus or minus 1 plus or minus 2 plus or minus 3 keeps on going up like that. So no decimals. None of these have any decimals. None of these have any fractions that don't give you a whole number, or like an integer value like that. We call these the integers. And these have two symbols. Usually it's Z that they're used, that's used for this one. But sometimes I've also seen that I is used as well. That's not Roman numeral 2. I think I can do it a little better. Sure. Or I is used. Typically, I'll bounce back and forth, but I'll try to keep on using this one because that's a little bit more mathematically correct. Z for the integers. And the other one that we'll take a look at is the real number system. I can't actually write down everything in the real number system, but imagine any single number that you would ever can imagine. Fractions included in that. Fractions, irrationals, so like the unit that we came to, like root 2 or pi, fractions, 9 over, 5, and everything above, right? And also, 0 plus or minus 1 plus or minus 2. There's infinite of these. We call that the real number system. Real numbers, and this kind of has the denotation of R, and then kind of with an extra little thing, so the real number system. If you're continuing on with pre-cal, this is the one that we usually use, the real number system. We don't really care too much about these. If you're continuing on with applied, then kind of a toss-up between these. Sometimes it's whole numbers. Other times we don't want to include zeros, so we say the natural numbers. Other times we can include negative numbers, but we want them to not have any decimals or fractions, so we say integers. So just a kind of couple of little things about that. I do want you guys to know that the real number system, when we do go into domain and ranges and stuff like that, sometimes it will be referred to as like negative infinity to positive infinity. This is our infinity sign. We'll be using these two symbols when we look at domain and range in a certain notation set. So this is infinity. Infinity, you can never equal it. This is negative infinity. This is positive infinity. You can never actually equal infinity. It's just a concept. You could give me the biggest number possible, and then I could say, oh, well, just plus 1, and then just keep on doing that by iteration. And infinity is nothing that you can actually equal, but it's something. It's more of a concept in mathematics. But the real number system would have infinite values. Which is kind of cool because I could say, if I had something like a number line here, and I had -1, and I had +1, and I had 0, if we were in the real number system, there would be an infinite possibility of numbers in between this. There are infinite numbers between -1 and 0 if we're in the real number system, right? If we're in the integer system, well, then there isn't, right? It's just -1 and then 0, and that's it. If we're in the rational system, then there would be other things as well. But, if we're in the real number system, there's infinite numbers in between these. Same with 0 and 1. Same with -1 and +1. Because I can just say, oh, right over here is like -0.999. And then I can say over here, well, that was actually -0.99. And I can just keep on adding nines or keep on adding decimals upon decimals upon decimals in between these to get an infinite amount. So real number system, we use that with a lot of pre-cal type of stuff. So grade 11, grade 12, we basically use real number system for everything. Applied, we'll still use real number system, but it's more of a focus of this because this is what more applications will tend to go to. There's going to be some sort of bound or maximum or minimum value. So really this is kind of more of an applied type of a topic is going to be these ones. Pre-cal, more of this. Since we're in pre-cal and applied, or intro to pre-cal applied, we use both in this course. I'll also say one other thing. A lot of the times natural, whole number, and integers, these are used for discrete data. So certain points that you can't have like half values for, decimal or fractional values are, where our real number system is used for continuous data. So like anything that has a line drawn through it, that's a continuous data set. We can get values anywhere in between things. We use the real number system, and we'll see both of those. So just a little FYI about unit systems and kind of how we're going about that in this unit and in this section.